Here we go, chapter 2, section 1a, quadratic functions. What makes something a quadratic function?
X squared.
An x squared, exactly. Okay, a power of 2. So, on f of x, I got x squared plus 6x plus 2. That's called a definition quadratic. That's what you're most accustomed to. However, if you look at part g, g of x is equal to 2 times the quantity x plus 1 squared minus 3. That's the stuff we're going to be working with this year. Okay, that's in vertex form or what's called standard form of a quadratic. Why is m of x a quadratic? I don't see an x squared. And you told me the definition was when you have a squared. You foil it. Okay, after you foil it, it's in factored form, then it would also be a quadratic. So, the shape is a parabola, and it either opens up or it opens down. True?
True.
It opens up when the a value is what? Positive. It opens up when your a value is positive. It opens down when your a value is negative. Now, we talked about these things called relative maxes and relative mins. If it opens upwards, it has a relative what? Minimum. Okay? If it opens downward, it has a relative maximum. Okay? Do this with your hand. Do it. I don't mind if you do that in class. I really don't. Okay? I can't chop off your hand. That'd be weird. All right? So, you're more than welcome to use it. On these graphs, my parent is x squared, my standard parabola. What's going on when I go from x squared to 1/3 x squared?
It gets fatter.
It gets fatter. Okay? That means the a is between what? 0 and 1. All right? And then if you look at part B, I go from x squared to 2x squared. What's that graph doing?
Skinnier.
It's getting skinnier. Why is it getting skinnier? Because a is what? Above 1, greater than 1. All right? What kind of transformations is happening here? I know, we're going back to 1.8. That's crazy. What kind of transformation is happening here? You can just orally say it. Like
Non-rigid.
Non-rigid. Okay, this is a non-rigid transformation. Okay, rigid means it does what?
Moves.
It moves. All right, it flips. It moves left. It moves right. Moves up. All right, this right here is where we're going to spend the bulk of our time. So a standard form of a quadratic, I would highly advise you write it down, know it by heart, is when you have f of x is equal to a times the quantity x minus h squared plus k. Where h and k is your what? Is your vertex. So your vertex is in h and k. And then you should notice some things. If I have this in what's called standard form, some books or authors call it vertex form. So just like you have synonyms for like X-Intercept also could be called a root or a 0, standard form of a quadratic could also be called vertex form. So if I say either one, you should recognize that. All right, I don't know what your college professor will say, but they could say either one. Or SAT, they could say either one, and you should be accustomed to it. All right, so if my A is positive, that means it does what? It opens up, which means you have a relative min. If my A is negative, that means it opens down, which means you have a relative max. And that relative min or max would be your vertex. All right? So if I have that, that's in definition quadratic form. True? And I want to put that into standard form of a quadratic or vertex form of a quadratic. And the way we do that is what we call completing the square. Okay, so we're going back to completing the square. And I want to start off with this easy one. All right? Remember completing the square, we deal with these two that have our variables. So then we end up with y is equal to x squared minus 8x plus blank plus 5 and then minus blank. Why do I do plus something and then minus something? So they cancel, right? Okay, because I'm just manipulating the way it looks. All right? We're not changing the value of this equation. We're just changing the way it looks. So now we're going to complete the square. So we take our b. So my b is what? Negative 8. So I take negative 8, and then I'm going to divide by 2. And then I'm going to square it. I highly recommend you don't skip this step right here. Okay? You're going to make more mistakes if you try to skip that. So I take negative 8 divided by 2, which is negative 4, quantity squared, which is, so I added 16. So what else do I need to do? I need to subtract 16. Math's equal opportunity sport. All right, so we're just manipulating it, right, Gunnar? All right. So then I end up with y is equal to the quantity of x. Now, what is this negative 8 divided by 2? All that is negative 4, right?
Yeah.
So I just drop it like that. Okay? And then I end up with minus 11 at the end, because 5 and negative 16 is negative 11. Now, truly what this x minus 4 is this factored. Okay? It's that factor. That would factor to x minus 4, or also known as x minus 4 squared. Are you following me? All right? But if you do this step, you can just drop it in right there. Now, what would be the vertex there? 4, comma, negative 11. All right? Which way would it go? Up or down? It would go up. All right? So now we know. Look at this one. So this one I have the equation 2x squared plus 8x plus 7. And I'm going to find the vertex, axis of symmetry, and I'm going to sketch this thing. So I have 2x squared plus 8x plus 7. Now, what's wrong with this one? It's in definition quadratic, true. But what else is wrong with it? There's a coefficient. Exactly. There's a coefficient. It's got a what? It's got a 2. I want to factor out a 2. And the only time we factor out a 2 is the ones with the variables. We don't do it with our constant, in this case 7. All right? So I'm going to factor out a 2. So now I have x squared and then plus what? 4x. And then we're going to start getting in that form. So I do plus blank, then I still have plus 7, and then I say minus blank. Okay? So now I'm ready for my completing the square. So what's my b value that I need to take? 4. So I'm going to take 4 and do what? Divide by 2 and square it. I highly recommend you don't skip that step. So 4 divided by 2 is? 2. 2 squared is 4. Did I add 4? This is a trick question. Did I add 4?
No.
No. What did I add?
0.
Nope. What? I added 8. I added 8 because this is really 2 times 4. Are you following me?
Yeah.
I really added 8. I put a 4 down, but I forgot what I factored out before. I factored out a 2, so it's 2 times 4, which is 8. So I added 8. I need to subtract 8. Okay? So now we're about ready for our good form, or our standard form. So now I have 2 times the quantity. X what? 4 divided by 2 is 2. So now I have plus 2 right there, squared. And then minus 1, because 7 minus 8 is negative 1. All right? So what's my vertex? Negative 2, negative 1. Good. So I have negative 2, negative 1, so I put it right there. All right. Now, which way is it going? Is it going up or down?
Up.
It's going up. And technically, is it fat or skinny or regular?
Skinny.
It's skinny. All right. It's skinny. So technically, we should make it slightly skinnier. I'm not going to be that rigid on my non-rigid transformations. Not yet anyway. Okay. So that's all I need for the little sketchy sketch. All right. So now we also need to talk about its axis of symmetry. All right, its axis of symmetry is this little line right here. You see how it reflects on each other? All right, so my axis of symmetry is what? X equals negative 2. Now, guess what I have to take off points for every year? Guess what they say axis of symmetry is? Negative 2. It's not negative 2, it is x equals negative 2 because it's a line. Are you following me? Just like if you say x-intercept is negative 2. No, it's not. That's a number. It would be negative 2, comma 0. You following me? So x equals negative 2 is my line. So this one, I have negative x squared plus 6x minus 8. So we're going to sketch the graph. We're going to find the vertex. We're going to find the axis of symmetry. And this one we're even going to find the intercepts. All right. What is wrong with this negative x squared plus 6x minus 8 equation?
Negative.
What?
Negative.
It's a negative in front. How rude. So what could we do? I can't Star Fox it.
Factor it out.
I could factor out a what?
-1.
I could factor out a -1. So let's factor out a -1. But we're only going to do it with my x's. All right, so I factor out a -1, and then I'm left with what? X squared minus 6x, and then plus blank minus 8 minus blank. All right. So what's my b now? -6. So now I take -6 and then do what? Divide by 2 and square it. So -6 divided by 2 is what? -3. -3 quantity squared is 9. Did I really add 9? No. How much did I add? I added -9. So if I added -9, now I need to subtract what? -9. All right. So if I subtract a negative, that's really doing what? Adding a positive. All right. So now I'm ready for my good form. So f of x is equal to -1 times the quantity. This is why I don't want you to skip this step. X what? -3 squared, and then plus 1. All right. Guys, do you see how easy it is if you don't skip this step that you can just drop them right there? All right, just, all right, drop them like it's hot. All right, good. All right, so now what's my vertex? 3, 1. All right, so let's start sketchy sketch. 1, 2, 3, 1. Which way is it opening?
Down.
It's going down. Why is it going down?
Negative.
It's a negative a. Okay, so it's going down. What's its axis of symmetry? X equals 3. All right, why is it x equals? Because it's what? A vertical line. A vertical line. All right. Now we're asked to find x-intercepts. Well, how do we solve for x-intercepts? We substitute in 0 for what? For our y value. In this case, our f of x value. So now we say 0 is equal to -1 times the quantity x minus 3 squared plus 1. What's my first step in order to get to x? I subtract 1. So now I have -1 is equal to -1 times x minus 3 squared. Now what? Divide by what? -1. Choom, choom. Now what? I square root it. Okay, when I square root both sides, what needs to happen? I get a plus or minus. So the square root of 1 is really 1. So I get x minus 3 is equal to -1, and x minus 3 is equal to 1. So when I solve both of those, I get x is equal to what? 2, and x is equal to 4. And I leave it just like that. No. Okay, I don't leave it like that. Because they're x-intercepts. So what would be the ordered pair? 2, 0, and 4, 0. Doesn't that make a whole lot of sense when you look at this little graphy graph? Does it not look like it's going to cross at 2, 0, and it's going to cross at 4, 0? All right. Now, every now and then you're going to get a question like this. What if this A were positive? Same vertex. If my A would be positive, it would have a function going like that, true? Yes. Would that have any x-intercepts?
No.
It would not. All right, so when you solve that, when you solve it algebraically or analytically, you're going to get a square root of a negative number. Can you get a square root of a negative number? No, not in real life anyway. All right, so you'd have no x-intercepts. I need a reader. Becca, call somebody.
Sarah.
Go ahead, Sarah.
Write the standard form of the equation of the parabola whose vertex is 1, 2, and that passes through the point of 3, -6.
All right, fantastic. So a standard form of a parabola. Well, what's that? Y equals what? A times the quantity, x minus h squared, plus k. All right, we're going to get to know that guy pretty well. Now, it gave me a couple things. It gave me a vertex, so that's cool. What's my vertex? H and K. That gave me my H and K. True? All right. So let's substitute that in. So now I end up with y is equal to a times the quantity x minus what? 1 squared plus 2. And then that gives me passing through a point, a solution point basically. So what is this 3, negative 6 thing? That's my x and y. All right. So what's my y? Negative 6. So now I have negative 6 is equal to a times the quantity. What's my x? 3 minus 1 squared plus 2. All right. So now we can solve. So what are we going to do both sides? Subtract 2. So now we end up having negative 8 is equal to 3 minus 1 is 2. 2 squared is 4. So now I have 4a. And then I divide by 4, so I get a equals what? Negative 2. So now I'm going to take that and do what? Substitute back in der. So then I end up with y is equal to negative 2 times the quantity x minus 1 squared plus 2. All right. Pretty cool. Now, you can actually know a lot from this equation. What's my vertex? 1, 2, right? Which way is it going? It's going down. Is it fat or is it skinny? It's skinny. Will it have intercepts? Yes. Okay. Pretty cool. All right. Turtle. B or turtle. The page number is the first part of chapter 2 exercises. I don't really remember the page.